Hey folks, it's Mr. Roy again. This is to give you a head start on some stuff for tomorrow about mechanical energy in a system and to give you a little background for playing with the simulation, one of the PHET simulations on the iPads and talking more specifically about how energy forms are connected to one another. So in this unit, we're talking about forms of mechanical energy. So in this case, so far, we talked about kinetic energy, we've talked about gravitational potential energy. Let's look at how those things are related. So when we talk about total mechanical energy in a system, we're talking about these two things added together. So we can imagine that we might have an object at the top of its journey, like a flower pot on a window, kind of like this one up here. It's got just gravitational potential energy. As it starts to fall halfway down, half of that gravitational potential energy will be transferred into kinetic energy. And then by the time it gets to the bottom and smashes on the ground, or just the instant before it happens, all of that gravitational potential energy will have been transferred into kinetic energy. So at any point on this journey, we can just add up the amount of gravitational potential energy and the amount of kinetic potential energy, and that's going to be the same total amount of energy throughout that whole journey. So we can actually say that the initial mechanical energy is going to be equal to the final mechanical energy. So even though the kinetic and gravitational potential energy amounts will change as that change in height happens, the total energy before and after is going to be the same. So in a closed system where we're not losing energy to friction through things like air resistance or other forms of friction, things like that, we would say that the initial kinetic energy plus the initial gravitational potential energy equals the final kinetic energy plus the final gravitational potential energy. All the energy will remain in the system. The only time this gets thrown into whack is if there's energy removed from the system due to friction. We call that an open system. Then we may have to add in this term here where we've got the energy removed from the system due to friction. So the total energy at the beginning would equal the total energy at the end, including some of that energy that's removed from the system. Those two sides would be equal. So that's what we're talking about when we're talking about mechanical energy in a system. You're going to see this in the PHET simulation in the skate park, where our kinetic and gravitational potential energy will oscillate and will vary. And when you're doing the part with the friction, you'll see that as our skater keeps going, more and more and more of the energy is lost to heat due to friction. But you're going to see that the total energy never changes, and that's a really key idea, that energy isn't created or destroyed, it's just transferred from one form to another. Okay, so it's time to try out the skate park. Enjoy, have fun, and I hope you have a great time virtually skateboarding.